Okay, so what we're going to be talking about is solving equations. And this is for algebra, chapter 3. If we go back to lesson 1 reviews something that you already know. Okay? In lesson 1, we reviewed about just the goal of solving. Whenever you're solving an equation, you're getting the n, or the variable, by itself. And so we learned some steps on how to do that. First, you want to isolate. You want to get the coefficient and the variable by itself on one side. So you want to add the opposite of the other number to both sides. Look at this one. 2n minus 5 equals 7. If we insert a plus sign here, we see that this is really negative 5. And so by adding 5 to both sides, you get rid of the negative 5 on this side. When you add 5 to this side, you got 12. So then you've got the coefficient and the variable by themselves on this side. 2 n's equal 12. And if you divide by 2, you can cross out the 2's. Divide by 2 on this side, and it shows n equals 6. Okay? Now this type of equation, this has a fraction in it. And we follow the same procedure as before, getting rid of the negative 9 first. So you add 9 to both sides, gets rid of the negative 9, and gives the 9 on this side. Then, to get rid of the fraction, multiply by its reciprocal. This is 1/3, so we multiply both sides by 3, or 3 over 1. And that gets rid of this 3. The x is now by itself, and that proves that x is 27. Okay? So, reviewing that procedure, we know we want to get the variable by itself on one side. Okay? Now in this lesson, we're going to have to simplify on one side of the equation first. In other words, there'll be some numbers that we can combine. We can add like terms together, can't we? So, look at this example. We have 2 c's plus another c plus 12 on the left side of this equation. 2c plus c, we know we can add because they are just exactly alike, right? 2c plus 1c is 3c, yep. And we want to keep the 12. We can't add 12 to anything because there's no other like terms, there's no other numbers that we can add. So we can simplify this to 3c plus 12 equals 78. And now we can solve it. We do the same procedure as before. Let's look at solving this one. If you have 3c plus 12, you add negative 12, and you want to start on the side with the variable to get the variable by itself. Add negative 12 so that we have 0 plus 3c, and on the other side we have to add negative 12, and we get 66, right? Then, since 3c plus 0 is 66, that means 3c is 66. Then, our next step, we can divide this side by 3. Divide this side by 3. You have to do the same thing to both sides. Cross off the 3's, so we're left with 1c, and divide. 66 divided by 3 is 22. Right? Now, let's take a look at this example. This example has the distributive property in it. In other words, we have a number outside of these parentheses. And so we learned in that situation, you have to multiply this number by every other term that's inside the parentheses. We know that this is a plus -4, so we're multiplying -2 times b is -2b, and -2 times -4 is +8. So we had to simplify this first before we could solve it. Now we could solve this. -2b plus 8 equals 12. Add -8, add the opposite of +8, so we get 0. And add -8 to this side, you get 4. Then bring down the -2b so that we can get rid of the -2's. Divide both sides by -2, and that proves b is -2. Okay? So we're just doing a few things before solving to simplify this in order to be able to solve it. Let's look at another one from your book. Let's look at example 4. Solving an equation that contains fractions. In example 4, we've got a problem with some fractions in it. You've got 2x over 3 plus x over 2 equals 7. Now, we really love working with fractions, don't we? No. What if we could get rid of these fractions? That'd be awesome, wouldn't it? We could get rid of these fractions. You can do that. You can multiply by the common denominator to get rid of the fractions. Okay? Look. We could put this in parentheses and multiply all of this by the common denominator. What's the common denominator? 6. Yep. 6 over 1. Now, when you multiply 6 times 2/3, since 3 and 6 are multiples, they're related, 6 and 3. 3 goes into 3 once, 3 goes into 6 twice. So we simplify this to 1 and 2. Okay? So 2 times 2x is 4x. We can do the same thing. We have to go back to the 6 because we're multiplying the 6 by x over 2. But 2 goes into 6 3 times. So we can simplify this to 1 and 3. Now do 3 times x. And that's 3x. And then, whatever we do on one side, we have to do on the other side. We have to multiply by 6 on this side. And we're just changing the problem, rewriting it. Okay? So 4x plus 3x equals 42. Can we add these together? Yeah, they're like terms, aren't they? 7x equals 42. Then, divide by 7, cross off the 7's, and that proves x is 6. Okay? So, what we're doing is multiplying both sides by the common denominator. And it eliminates these fractions. All right? That might come in handy whenever you're working with fractions. Okay?